Looks like we have to go over all of them.
Yes.
Well, I got a video 7 and 8. Boo!
Huh?
I have to do video period 8 because somebody's absent.
Oh, it's okay.
That's exciting.
Yeah.
It's a special account.
Oh, it's cold. Okay, so number 7. Compute the surface area. So if you solve for z, z equals 1/3 times, gosh, I can't even read that. X to the 3 halves plus y to the 3 halves. I see it already.
No way.
What?
X goes from 0 to 1, and y goes from 0 to x. Come on! So what is the partial of z with respect to x?
X.
1/2 x to the half. The partial of z with respect to y is equal to 1/2 y to the half, right?
Mm-hmm.
So the double integral is the square root of this thing squared, 1/4 x, plus that thing squared, 1/4 y plus 1 dx dy. But if you integrate with respect to y first, it's going to go from 0 to x, and then you integrate with respect to x, it's going from 0 to 1. Can we at least set up the integral?
That's where I got stuck.
Yeah.
Really?
Yeah.
So if you integrate with, are you kidding me?
No.
Now, do you want to factor out the 1/4 from this?
Oh, wait, you just treat 1/4 x as a constant.
Yeah, it's a constant, that's why. This is like easy.
Oh, wait.
Okay, wait, why don't we factor out the 1/4, and that just becomes x plus y plus 4 then, how's that?
But if it's weird,
Well, you
then
can-
what do you want to
yeah.
have?
Yeah, that's what I said. And take out the 1/2. Alright, so what is the integral? You gotta remember, x and 4 are constants when you integrate with respect to y. So, isn't the antiderivative of this just gonna be x plus y plus 4 to the 3 halves with the 2/3 in the front?
Yeah.
Because x and 4 are constants.
Oh.
So basically it's just like y plus 1. What the heck was that? And then you integrate from 0 to x. So if you plug in 0 for y there, x for y, you get 2/3, 2x plus 4 to the 3 halves power, minus, and if you plug in 0 for y there, you get 2/3 x plus 4 to the 3 halves. Did I do that right?
Yeah.
Okay, then you have to integrate that with the 1/2 with respect to x from 0 to 1. But come on! So 1/2, okay, what's the antiderivative of this one? Park.
Wait, can you factor out the 2/3?
2x plus 4 to the 5 halves with the
With the 2.
2/3
2.
times 2
Oh, sorry. 2/5.
with a 2/5 in the front,
Yeah.
as well as a,
2.
no,
What?
a 1/2. Because the derivative of the box is 2, so you gotta adjust for the 2 with the 1/2.
Oh, yeah, you're right. Wait.
Of course I'm right.
Wait. Oh, yeah.
If the derivative of the box is 2, you gotta put a 1/2 to cancel it out, right? Just like this, what's the antiderivative of cosine 2x? Is it just sine 2x?
Hey, sorry.
No, because they left the space for a 1/2.
Okay, what was the original?
Right here. The derivative of the box is 2, so you need a 1/2. No way, this is review. No way. You're like a blind man in a dark room looking for a black cat who's not there. No way. Like a shot in the back.
Okay.
Those don't seem similar at all.
And then this one is x plus 4 to the 5 halves with the 2/5 in the front. How come don't have the 1/2 like this one? Because the derivative of the box is 1. How come you guys are looking like, huh? Huh? Do I need to go any further? This is gonna be ugly. You got like 6 to the 5 halves power. Is that what they have in the answer? 6 to the 5 halves? 36 root 5?
I don't know.
How did you answer?
Okay, I'm gonna, besides the 1/2, I'm gonna factor out a 2/3 times 2/5 as well. What is that? That's a 4/15. Okay, what's gonna be left? Plug in the top number, 1/2 times 6 to the 5 halves power, minus, what happens when you plug in 1 there? 5 to the 5 halves power. So this comes out to 2/15. What is the 6 to the 5 halves? That's 36 root 5 over 2 minus 25 root 5. Is that correct?
But what about the 0?
Oh yeah, gosh. That's a major mistake right there. Minus, if I plug in 0, you get 1/2 4 to the 5 halves power minus 4 to the 5 halves power.
Okay.
Okay, minus, so that's gonna be 16, no, 4 to the 5 halves we can actually compute. Square root it and raise it to the 32, so 16 minus 32. You guys can take it from there, yeah?
Yes.
Okay. Well, let's get the final answer. So this is like 50 over 2. So 2/15. So what is that? What is 36 root 5 over 2?
-7.
Negative
Oh, yeah.
7 root 5. And then that one is negative 16, but it's positive. Is that the answer they have in the back? We'll just assume it is.
No.
Let's check. Yeah, I got it.
Well, you guys,
Fine.
Number 7.
we picked up all the errors, so that's gotta be it, right?
What is
It's 1 over 15, 36 root 6 minus 50 root 5 plus 32.
Oh yeah,
32.
how can we add these together? Because look how stupid that is. This is a root 6, it's 36 root 6.
Oh, yeah.
It's not a root 5.
Yeah.
That's so dumb. Okay, so 2/15, 18 root 6 minus 25 root 5 plus 16. So you said they only put a 1/15 on the outside, so it's gonna be 36 root 6 minus 50 root 2 plus 32.
Yeah.
There you go. That's dumb right here, that was dumb.
And then.
No, you're supposed to say there's a B at the end.
Oh.
Okay, number 9. So that was a simple integral that turned into a nightmare. So number 9,
Yeah, this was a really long one.
What's he doing?
I don't know. X squared plus y squared plus z squared minus 4z equals 0. And it says, we're finding the surface area.
Yeah.
Okay, wait. So, wait. 0, I gotta process this thing here. 0, 3, x squared plus y squared, z squared. That's weird. Z is greater than or equal to 2. So we need to solve for z. How the heck do I solve for z?
You can.
You gotta complete the square. What do you mean you can't?
Oh.
Add 4 here, and so you get x squared plus y squared plus z minus 2 quantity squared equal 4. Hey, you want sphere. Where's the center of the sphere? 0, 0, 2, radius 2. So, we're talking about a sphere like this. Whoa! Ah! Where's love when you need her? Does that, okay, whatever. But now we need to solve for z. So how do you solve for z? Z minus 2 squared is equal to 4 minus x squared plus y squared. And then square root both sides. How come I take the plus 1?
Oh, Oh,
How come I do the upper half
Z
of,
is greater than.
because z is greater than 2, so it's the upper half of the sphere. Yeah. So z is equal to 2 plus root 4 minus x squared plus y squared. Probably we're gonna do this in polar, yeah?
Yeah.
Oh.
Okay, so let's do the partials. What is the partial of z with respect to x?
Negative x over 4, the square root of 4 minus x squared plus y squared.
So
Wow.
1 over, I can't do that in my head.
No, it's right.
Okay, so 1 over 2 root box times the derivative of box, which is negative 2x. And the 2's cancel out.
Yeah. That
Okay.
was the same thing.
And then the partial of z with respect to y is going to be the same thing then, yeah? Negative 2y over 2 root 4 minus x squared plus y squared. And they cancel out. So now we can write the integral. The double integral of the square root of the partial of this squared. So that's going to be x squared over 4 minus x squared plus y squared. Plus this one squared, y squared over 4 minus x squared plus y squared, plus 1 dx dy. Okay, now we gotta figure out what the heck this means. So so it's the upper half, but z squared, what? X squared plus y squared is less than or equal to z squared over 3.
Yeah, what does that mean?
That's what we have to decipher that.
Oh, wouldn't it be like R is between 0 and Z squared over 3?
Oh, so if you think of this as polar, that's r squared then.
So, yeah.
Oh,
Huh?
so r, if you square root it, then r is between 0 and z then.
Huh? No,
Wait,
but
what the
the
three?
three. Well, yeah.
Oh!
So what
The three.
R will be between 0 and z
Over
over
root
root 3.
Oh, that's smart.
But then what about the negative?
Well, wait,
It's
wait.
squared, which have a negative.
No, but you're
No, because
taking
it's
R.
greater than or equal to
Taking
0.
Oh.
It's greater than or equal to 0.
R.
Wait, so what is z
It's
over
greater
root
than or
3?
equal to 2.
Zero root three is zero root three.
Okay, I'm having trouble visualizing this.
We do a z squared then.
X squared plus y squared is less than or equal to z squared over 3.
Or if you did, then you're gonna have Z in your answer.
Can you put the 2 into the z squared?
See that again?
So like substitute z squared for 4. So then 3x squared plus y squared is less than or equal to.
No, we have to know what this graph is gonna be.
That's a circle. Is it?
No, but the z squared got that
Oh.
z.
Z is the
for round.
radius?
I don't know.
No, isn't that
That's
wait,
a
wait, wait,
sphere,
time out.
that's a
No,
sphere.
no, we know that graph. If you made this an equal sign, we know that graph. In fact, it was on the test. Remember the
It's a
quadratic
logic
surface?
paraboid, it's a
No.
hyperbolic
Oh,
paraboid,
no,
it's a.
no.
Hyperboloid.
No.
It's the thing with the cross sequence, the
Okay,
cones.
so what is that?
Quadricone.
The quadracone.
I
We
said
can't.
Oh, you said cone.
Yeah.
That's the
Actually,
quadracone. So what does the quadracone look like? I'm trying to draw the quadracone here. It's gonna look, but I'm trying to think in terms of the sphere. Well, why don't we do this then? What's the equation of the sphere? This. So what can I substitute for x squared plus y squared?
R
Z squared
Oh.
over 3. Correct? If you think of it as an equal sign. Did I do that correctly? No, I'm trying to think of, because the quadracone is going to come up like this, yeah? But how is it going to intersect this sphere over here? Like, how do you figure out where they intersect? Or do we even have to worry about that?
I
So, we just assume, no, we can't assume anything. The quadrant cone is gonna be like this then? Like that? Yes or no?
I'm trying to solve this while I'm listening.
Oh, it's amazing you can do two things at once.
Or I tried.
The quadrant cone. Well, no, think about it. Do we really have to fix? Yes, because remember, we gotta smash it down onto the XY plane. We gotta know where it intersects.
That's just a circle.
Huh?
Is it not?
We gotta know where it intersects the sphere. We have to. Oh, but if we
But
smash
yeah, it's not gonna intersect. It's gonna be two big circles. It's just gonna be a bigger circle and a smaller circle, right? It's not gonna intersect.
Oh, yeah.
No.
But if you
But what if
smash
it
down-
like intersects like up there? You know what I mean? That's what I think is gonna happen.
No, but
It's
if you
gonna
smash
inter-
it down, it's not
It's gonna be like a sphere like this. No, but then it's gonna be like this. So if you smash it down, it's gonna be this part there.
Just assume
Oh.
midpoint.
That's what I think it is. So we have to figure out where the quadrant cone intersects the sphere. Come on, help me out here. Park,
Jason.
instead of falling asleep.
X squared plus y squared plus z squared.
So
Wait,
this is it
wait,
right here.
wait.
How do you find where this graph intersects this graph? Don't you just substitute in?
Yeah.
Oh, can
Do
you
that.
just do z
Okay.
squared over 3 plus?
Okay, right here. Let's substitute it in. This
Yeah.
is z squared. Well, yeah, we're gonna get it right here. So we got 2z squared over 3. Is that right? No.
No.
4z squared over 3 minus 4z equals 0.
Times 3.
4z squared minus 12z. Tell me if I make a mistake. Factor out of 4z, you get z minus 3. So z is either equal to 0 or 3. Correct? See? When z is 3, that's when it's going to hit. Right there. It's like, okay, here. Gosh, where's my picture? Gah! Right there. Z is 3. The z coordinate is 3 there. See? So when you smash it down onto the xy plane, what are you going to see? And when the z coordinate is 3,
Oh, a circle.
okay, so
X squared plus
here's
y
the
squared
equation.
equals 3.
Here's the equation right
Equals
there.
9.
What happens if I substitute 3 for z? You get 9 minus 12, which is negative 3, right? So isn't that x squared plus y squared equals 3? So it's root 3. That is root 3 right there. So when you smash it down onto the xy plane, that's what it's going to be. Yes or no?
Yeah.
Yeah, so there you go. So what's the equation of the circle that's smashed down into the xy plane? X squared plus y squared equal 3. So therefore, y squared equal 3 minus x squared, y equal plus or minus the square root of 3 minus x squared. So if you integrate with respect to y first, shall we just put in the symmetry here?
Wait, what about polar?
Yeah, but let's do this first. So it's gonna go, oh yeah, you wanna do polar then?
I mean, it's easy.
No, but we
But
already
there's
have.
a circle.
No, but yeah, no, yeah, we wanna do polar.
So do we
Okay,
not
so
have
let's
to do
change
that?
this. Let's change this.
No.
So if I make a least common denominator inside the radical, you're gonna get 4 minus r squared, correct?
Oh, yeah.
Okay, so you're gonna get x squared plus y squared plus
That's
4 minus r squared, but then that's r squared. X squared plus y squared is r squared. But that cancels that.
Yeah.
And then you have a r dr d theta. R goes from 0 to root 3. Oh, what are we messing with? And then theta goes from 0 to 2 pi. Okay, so what integral do we have? This is the integral we have. 0 to 2 pi, 0 to root 3. So on the top we have a 2r. On the bottom we got root 4 minus r squared dr d theta. There's the integral.
Wait, why is there a z greater than or equal to 2? That's important.
Say that again?
Because the z is greater than or equal to 2.
That means it's the upper half of the semicircle, that's why. Otherwise,
Doesn't it end up being?
because over here, when you solve for z, actually it's supposed to be plus or minus, yeah.
Oh, yeah.
Okay, you guys know how to handle that integral, right? It rhymes with numaptutushin.
Wait, yeah, but then doesn't that not even matter, whether it's plus or minus, because you take the derivative, and then you,
Yeah,
and
it
then you
doesn't
square the derivative?
Oh, yeah, it's not gonna matter. Even if you've had the minus there, it would be the same thing. Okay, shall we just do it for funsies just to see if it matches the answer in the book?
Yes.
Okay, so if u equals 4 minus r squared, du equal negative 2r dr, so that integral becomes root u on the bottom. 2r dr is simply negative du. And then what are my new limits of integration?
4.
We're doing this one first,
Oh,
huh?
geez,
We're doing down first.
4, 1.
So if I plug in 0, you get 4, and if you plug in root 3, you get 1. So this is negative u to the half with a 2 from 4 to 1. Factor out the negative 2, 1 minus 2, and then we get 2. And then of course if you integrate that from 0 to 2 pi, you just multiply by 2 pi, so the answer is 4 pi. Ta-da! Is that the answer?
Yeah.
Okay, there we go. Yay, we got it! Okay, that was the hardest part of the whole problem right there, is figuring out that thing right there. When it gets smashed onto the xy plane. Alright, we gotta scroll. By the way, I made a new game.
Yeah.
Yay.
What is, oh wait.
Well, I actually made 3 new games.
Yeah.
So
Spell.
we're gonna cheat.
Yeah. We don't cheat. That'd be cheating.
What a great watching. What a great.
No wonder you guys had problems with this, because we had to think about that. You gotta think, what the heck is that? It's a quadrant cone. Hey, look at what you did.
Let's make it.
Can I erase this?
You want
Wait.
backwards?
Yeah, you
This is what we did.
Go ahead.
Yeah, you
I mean, what
Thank-
intro?
thank you.
My iPhone's gonna die.
Okay. Can you say?
How come it seems like I'm doing all the work?
And then I'll say, here's
You know what we did one time in this class? I taught them how to program graphing calculator. Because they were interested in it.
Oh. You need a
Are you,
formula, yeah.
are you interested in learning how to program your graphing calculator?
What does that mean?
Playing games and stuff.
No, not
Yeah, Pokemon.
like programming it for like mathematical and scientific purposes.
Like, what does that mean?
Also, like, you
How
can
does
like put equations and stuff, yeah? Like formulas.
No, not just write. No, like actually doing something.
Can we do that when after we're done with
We're just gonna barely finish, you know. Okay, what were the 2 questions that are assigned to this one? Somebody tell me.
20.
the
2C and D.
3?
2C. Okay, it says find the mass material on the shape of the triangle. Now, some of you came in for help. 1 person. And you guys were doing a triple integral. But we're not doing a volume. We're not finding the centroid of a volume. We're doing the
Oh, the
centroid of a surface. It's a surface.
Ah.
So it's a double integral. I did the example yesterday. Okay, so we have this plane right there. What is the equation of this plane? Okay, just by looking at it.
Oh,
That's
x
fine.
plus y plus z.
Okay, x plus y plus z equal a. That is correct. So if you solve for z, you get a minus x minus y. So what is the partial of z with respect to x? Duh, negative 1. What's the partial of z with respect to y? Double duh, negative 1. So the double integral is gonna go square root of negative 1 squared plus negative 1 squared plus 1
Oh,
dx
shoot.
dy dx. And then what is our, what do you call the thing? The density function? Kx squared. Kx squared. So you,
Why is this squeeze?
okay. So it looks like we need to integrate with respect to x first because of this, yeah? No, actually it doesn't matter. Which one you want to integrate with? You know what? I changed my mind. We're going to integrate with respect to y first. So if you smash this down onto the xy plane, you're going to see this, right?
Yes.
And so this is x over a plus y over b equal to 1. So if you, no, it's a. So that's x plus
I'm sorry.
y equal a. So y equals a minus x. So if you integrate with respect to y first, it's going to go to 0 to a minus x. And then if you integrate with respect to x, it's going to go from 0 to a. Here's your integral.
Wait, that's the answer for the second one.
Okay, but we're not there yet. Okay, now this is a constant. Throw it on the outside, man. Like that. So, and let's throw the k on the outside too, like that. Okay? So, how do you integrate x squared with respect to y? Actually, x squared is a constant too. It's just x squared y from 0 to a minus x squared. And so plug in the top number, a minus x minus 0. So that's just ax squared minus x cubed. Now we have to integrate that with respect to x from 0 to a, and then multiply it by k root 3. So what's the antiderivative of that? A over 3x cubed minus 1/4 x to the 4th from 0 to a. And then, let's just do it over here. K root 3, plug in the top number. A to the 4th over 3 minus a to the 4th over 4. And if you plug in 0, you just get 0. So, make a least common denominator. So that's going to be 4a to the 4th minus 3a to the 4th is 1a to the 4th. So k,
Yeah, that's
a
the
to
answer.
the 4th root 3 all over 12.
Yeah.
That's the answer? Yeah, because we didn't catch any mistakes. So what was the hard part about this one?
I didn't get like
The
it
partials.
was like P, right?
Well, I
Or row.
got to there,
Row.
but then the one.
There's no row in this problem.
Wait, isn't it rho xyz equals kx squared?
No, in the question it says like rho.
Oh yeah, because it's density function.
Yeah, that's just the density. Right from physics, it doesn't row usually represent the density.
No one did.
Yeah.
You guys
Oh
took
my
physics.
God, yeah, I thought
They
it meant,
use row for density.
I thought it meant use cylindrical.
Oh no.
Yeah.
Can I erase this now?
I really don't.
Okay. Finally, the last problem. At least you have, since we combined the two sections together, no homework tonight. Plus, there's no homework tomorrow.
Yay.
You guys were gonna do it
Wait,
anyway, right?
We're not learning.
Mr. Park, I wasn't gonna do anything anyway.
We were.
And what was the last problem?
3.
Number 3. Find the mass of the surface.
How is it 0?
How can a mass be 0?
Yeah, I screwed up.
Why, is the answer 0 in the book?
Yeah.
There is no answer.
So, how can you say it's 0? You
No,
didn't
no, I thought I read 0 in one of the answers.
Yeah, but this one doesn't have an
I said
answer.
this one. I.
And why is, come on, look at that. This is like, just look over. Okay, so what is the partial of z with respect to x? You guys gotta do something. Mark,
X. Negative X.
negative x. Partial of z with respect to y, duh, negative y. So your integral is gonna be double integral square root of that thing squared plus that thing squared plus 1. Does it look like we're gonna do polar on this one?
Yeah.
And it says the density at each point is proportional to xy. So kxy.
And you,
Wait, I'm thinking, do we still want to do polar?
yeah, and
Yeah.
you change it to R
Yeah,
squared.
Let's
I'm
do
thinking. Yeah, I think we do. R, dr. No, but then look at this thing. Look at that thing. No!
But then if you set z equals to 0, that's a circle.
Yeah.
What's it, what?
If you set z equals 0, like if you
Yeah,
smash it
and
down,
so then because 1
it's a
minus 1 half
circle
R
of
squared
radius
equals 0.
2.
Oh, okay, so if you smash it down.
Yeah.
No!
Why not?
Because of this.
Oh.
But the restrictions are the same.
So, this is, okay, wait, time out. This is a paraboloid. Where does it intersect the xy plane?
Z equals 0.
1/2, wait, I can't do this in my head, equal 1. So multiply both sides by 2, right? So it's a circle of radius 2, correct?
Root 2.
Root 2.
What did I just say?
2.
But I wrote root 2.
Okay.
Oh.
Don't listen to what I say, look at what I write, unless it's the opposite way around. But look at this. Yes, you can smash it down onto the xy plane, but this is where you want to integrate it.
Wait,
You
what?
understand?
No.
Yes, this is the region, however, x has to be between 0 and 1 only, and y has to be between 0 and 1. Because they gave you this in the problem.
But then isn't that like negative 1?
Yes, but the region is not the whole circle, it's just the square that's in the circle.
Okay, let's not do polar. then.
Yeah, that's what I'm saying, so I don't think we should do polar. So this is, if we integrate with respect to y first,
exactly.
it's gonna go from 0 to 1.
Yeah.
And then if you integrate with respect to x first, it goes from 0 to 1. Yeah, now,
That's what.
we can do that, use substitution, right?
Wow.
Oh yeah.
You said-
Wait, first of all, you understand what I'm talking about here? It's not the whole circle because they tell you this.
Yeah.
Because, yeah,
Okay.
otherwise they would have said x squared plus y squared is less than or equal to 2. I guess they would have put that, but that's kind of
But on the
redundant.
picture you shaded, isn't it negative 1?
Yeah, except you times it by 4.
What? No, the range is 0 to 1.
Yeah, but.
Oh,
on
it's
your
only,
pic-
it's only,
I thought- I
ha!
Wait.
You almost mixed me up there.
said- Wait, but on your picture, your X is from.
Yeah.
Okay, sorry.
That's what I was
sorry.
confused about.
Okay. There. Okay, now that clears it up. Okay, now can we do the integral?
Yeah.
I'm gonna throw the k on the outside. Now, x is a constant, so why don't we throw that on the outside? So let's do this integral first
What
right
is
there.
it? Use substitution.
Yeah, use substitution, this is easy. U equals x squared plus y squared plus 1. Du equal 2y dy. So this integral is the square root of u, and y dy is 1/2 du. And what are my new limits of integration? If I plug in 0 for y, you get x squared plus 1. If I plug in 1 for y, you get x squared plus 2. Those are your limits. So that equals 1/2 u to the 3/2 with the 2/3 in the front from x squared plus 1 to x squared plus 2. Oh, now this is SU substitution. So this becomes 1/3 times x squared plus 2 to the 3/2 power minus x squared plus 1 to the 3/2 power. Okay, is everybody checking?
Yeah.
Okay, now we gotta integrate that with respect to x. I'm gonna remove this equal sign. We're gonna integrate this with respect to x, but then there's an x now from 0 to 1. And it looks like both of them you can do u substitution. In fact, what the heck, why don't we just do a massive u substitution?
Oh. That's very.
Or shall we break it up into two separate integrals?
Do the math one.
A massive u
Is
substitution.
it u squared and one of them can be u squared plus
Okay,
one?
so wait, I'm trying to concentrate. U equals x squared plus 2 to the 3/2 minus x squared plus 1 to the 3/2 power, like that, massive.
Oh.
So du equals, wait a minute, what the heck am I doing? There's no massive. There's nothing massive about it. Sorry. I thought I saw something clever, but I didn't. Okay, so we just have to split it into separate integrals. So we got the integral from 0 to 1 of x squared plus 2 to the 3/2 power. Okay, Jason and Jason will do the first one. Minus, and Ha and Park will do the next one. Integral from 0 to 1, and I will do both, and we're gonna race and see who gets the answer first.
X squared plus 2 to the 5/2 times.
No, you guys do it.
Nice job, Jason. That's my answer too.
That's not that answer.
Oh.
I don't see people working.
For the first
Oh.
Okay, this is,
I have a head.
Or
Wait,
you can just do this in your head.
You.
Just like the movie. You know your times tables? Yeah, I know the ones,
no, I lied.
the twos, and the,
It's 1/5. X squared plus 2 to the 5/2.
Yeah, I think I agree. Looking at it.
u equal x squared plus 2. du equal 2x dx. u equal x squared plus 1.
hey, I got
Yeah, I agree with
I-
Jason.
So this integral becomes u to the 3 halves, 1/2 du from 2 to 3. Minus the integral of u to the 3 halves du over 1, 2, and the new limits are going to be from 1 to 2. So this I'm winning.
Wait.
I'm going to factor out the 1/2. U to the 5 halves times 2/5 from 2 to 3. I'm going to factor out the 2/5 minus u to the 5 halves times 2/5 from 1 to 2. So, well, 1/15 times, this is 3 to the 5 halves. That's going to be 9√3 minus 2 to 4√2 minus 4√2 minus 1. So I got 115, 9√3 minus 8,
2. Wait.
8√2. Stop distracting me and keeping me from winning. Plus 1. This is what I get. Is that-
This doesn't look like
Is that what the book says? Oh yeah, this one doesn't have an answer in the book.
You have,
Wait, what?
you have 0, Jason.
Yeah.
Okay,
Oh, yeah.
so did Jason and Jason get the first part?
Yeah, well, yes.
Yeah.
Yeah.
And did Park and Hog get the second part? Yeah, you guys are just nodding.
No.
no, my
I got up to the middle, I
Alright,
didn't
okay,
plug it in
good.
though.
Okay, there we go, that's the answer. See, these integrals are fun to do. Well, to me they're fun.
So fun.
Ah, okay, so like I said, no homework tonight, no homework tomorrow.
Yay.
That's because we put two, you guys are lucky we combined 9 point, whatever, 19 point
4,
something and 19 point something.
5.
Let the games begin!
Hey, this is on